section 3.5. Multiplication of radical expressions. This is a little more important in my estimation, but also, this is just something I want to spend a little time on because there's a big variety of problems. So let's take a very simple example. Let's take a very simple example. The square root of 2 times the square root of 10. And as you may imagine, this is equal to the square root of 20. No mystery there, right? That's makes sense to do the problem that way. And you get the square root of 20 is equal to, and then you simplify it, of course, because whenever you a radical, you want to then simplify it. And that's the answer to the question. But I don't want to spend that much time on that type of expression. I want to spend time on this. So let me show you what I'd really like to spend time on. And that's something that looks like this. And I'm going to ask you to try this based on what you know. I want to ask you to do this problem. Let me begin going over this. So this is what I'm doing. So, it's like binomials, multiplying binomials. 8 times, now the square root of 7 times the square root of 7 is equal to 7. And the reason is that the square root of 7 times the square root of 7 is equal to the square root of 49, and the square root of 49 is equal to 7. Maybe I should write that. Let's do it this way. Let's change the method. Let's change the method. Because that was sort of sneaky. This times this gives you the square root of 49. This times this gives you positive 3 times 8 is 24 times the square root of 7 times 5 is 35. Now this times this gives you negative the square root of 35. And this times this gives you negative 3 times the square root of 25. Now let me just check my own work here. So this times that, yes. This times that, yes. This times that, yes. This times that, yes. Okay. So the square root of 49 is 7 plus 24. Well, let's simplify this as we go along. This can be simplified, right? We have the same radicals, so this is 23. 23 times the square root of 35. That takes care of these 3. And then over there, 3 times 5. So this becomes 56. This becomes 23 times the square root of 35 minus 15. Then we can combine these two, and that gives us 41 plus 23 times the square root of 35. And that's all you can do. Very exciting problem. Only kidding. I don't think it's very exciting, but it's kind of an extension of the distributive property, right? You're distributing, it's like multiplying binomials, except it's a little more complicated. because you have radicals. But this is the way you do it. Are there any questions? Okay, next problem for you to try. Problem 3. The square root of W minus 2 times the square root of W minus 9. Let's see if you could do that. That's all the time it should take you, really, because what you're doing is, again, the square root of W times the square root of W is W. The square root of anything times the square root of anything is going to be equal to what's in there. It's that same theorem we spoke about. You want to call it a theorem. The square root of W squared is going to be equal to W. That's what's going on here. The square root of W times the square root of W gives you the square root of W squared, which is equal to W. And then -9 times the square root of W. And then this -2 times the square root of W. See, I saw this coming. So I decided to line them up to make it easier for us to combine them later on. And then this is positive 18. And there it is, W minus 11 times the square root of W plus 18. And that's, you know, it's dry, you know, there's nothing really, I mean, to me, this is not exciting. I'm not really, but that's the way, you know, we're just learning how to do various skills. Can anybody liven things up by asking a good question? No? All right, next problem. Again, try this. Problem 4. Where is it? Oh, here's the one. Square root of 3 minus 2 times the square root of 5 to the second power. It's like raising a binomial to the second power. Try that. Okay, let's begin. So what this means is the square root of 3 minus 2 times the square root of 5 times, because we're squaring it, the square root of 3 minus 2 times the square root of 5. That's what that means. Now you use the same process. The square root of 3 times the square root of 3 is 3. The square root of 3 times 2 times the square root of 5 is -2 times the square root of 15. Then here, negative, sure are a lot of 2's here. This.
Can you go over the camera?
Oh, yeah, good, thank you. Then this part is -2 times the square root of 15, and then -2 times the square root of, whoa, what's going on here? Oh, the square root of 25, which is 5. So that's what I was about to do, but you know, let's speed it up a little bit here. So here's what I did. Square root of 3 times the square root of 3 is 3. Then the square root of 3 times 2 times the square root of 5 is -2 times the square root of 15. Then you go to this term. 2 times -2 times the square root of 5 times the square root of 3 is another -2 times the square root of 15. And -2 times the square root of 15, square root of 5. See, this is a mistake. Here's a mistake, right? Nobody's going to point that out. 2 times 2 is 4 times this is 5. So this is what we get, I think. 3 minus 4 times the square root of 15 minus 20. And then we can combine these two, and the answer is negative 17 minus 4 times the square root of 15. Kind of a difficult problem. I see a mistake. Can anybody tell us what the mistake is? Ooh. Let's see if anybody can.
The 4 is supposed to be positive 4.
Who said that?
Yes.
Sandas, right. Very good. That's exactly right. This negative times that negative would make that positive, and therefore this part would not work. So, in other words, rather than negative 20 and positive 3, 3 and 20 is 23, minus 4 times the square root of 15. This is the answer to the question. Very good. Sanjas, that was a really good answer. I mean, it's not obvious because this is such a kind of a complicated problem. Okay, one last question. Do we have time? Because I have so much to do. I hate to do this, but it's like, you got to do a problem like this because this is like a nice problem to do. Try this problem. And then we'll move on to something else. So here we go. Okay, first do it and then we'll talk about it. First of all, what are these two binomials called?
Conjugates.
Very good. Excellent. Excellent. Yes. These are conjugate binomials, right? So this times this is equal to, now the square root of something times the square root of the same thing is just going to give you that. Right? But let's put it in parentheses. So it's like, just so it doesn't get in the way of everything. Now, we don't really have to then multiply this times this and this times this, but we will because we know what's going to happen with conjugate binomials. Conjugate binomials always have that middle term dropping out. And then this times this is negative 49. So this is what happens. The fact that we've multiplied conjugate binomials together, like here, means that this will drop out. And you don't even really have to do that. If you know that they're conjugates, you don't even have to bother. You could just multiply this by this and this by that. And this will be y plus 2 minus 49, which becomes y minus 47. And that's the answer to the question. Did anybody get that?
Yeah.
Yeah, you got it? Good, very good. Anybody else?
Rose.
Good. Anybody else? I should take attendance now and see who's even in class. How would you like that? Would you like that? Want to try that? Nah, I don't want to waste the time. Okay, that's it. That's all I want to do on multiplication. So remember when we did this back and we had 3 over I, and we wanted to get this denominator to be a rational denominator. So we multiplied by I over I, and this became 3I, and this became I squared, and I squared was negative 1 And the answer came out negative 3i. So we kind of did sort of rationalizing a denominator, except not with radicals. And that's what this section is going to focus on. It's going to focus on the concept of rationalizing a denominator when the denominator is a radical, which is a radical expression, such as that, which comes up very often in mathematics. We do not want an irrational number in the denominator any more than we want an imaginary number in the denominator. It's just easier to work with when this is a rational number. So what we do is the same thing. We multiply by the square root of 3 divided by the square root of 3. And this will become the square root of 3, and the square root of 3 times the square root of 3 is 3. And that's how you do the problem. That's called rationalizing a denominator when we're talking about radical expressions instead of imaginary numbers. Okay, get the idea? This is important. And this is something that we're going to see again when we do trigonometry in about a month. Okay, so this is something that's kind of important. So I'd like the class to do the following problem. So this will be number 1, this will be number 2. And this is what I'd like you to, and again, the instructions will be rationalize the denominator. Rationalize the denominator. And here it is. So do that problem. And I have confidence you will get it right. I think that if you're still following this stuff and you're trying the problems, what you probably should have done was to multiply by the square root of 2 divided by the square root of 2. That would have been the next step. And then you would have gotten 6 times the square root of 2 divided by 2. But you shouldn't have stopped there. What is the actual answer to this question? Anybody?
You simplify and you get 3 times the square root of 2.
Good. Very good. That's it. And that's the answer to the question. Okay, now let's go a little further. Let's go a little further. What if this were the problem? There's a key word here that I'm looking for.
I would say multiply possibly the numerator and denominator.
Multiply the numerator and denominator. Brendan is now speaking. By what?
The conjugate.
Good. There you go. Why didn't you just say that? Good. Exactly. Important concept here is the concept of the conjugate binomial. The conjugate binomial. We keep coming back to this, don't we? This is a concept that we keep coming back to. If I said to you, what is the conjugate binomial here? And you would say, well, the conjugate binomial is 5i plus 1. If I said, x minus y, what is the conjugate binomial? You'd say x plus y. And here we go again, the square root of 5 minus 1 and the square root of 5 plus 1. So these conjugates are constantly coming up because it's a very important concept in giving us a rational denominator. That's the point here. So the numerator is easy because that's just going to be the square root of 5 plus 1. But the denominator, now let's do it the long way first. So let me come down here and do it the long way first. So the square root of 5 minus 1 times the square root of 5 plus 1 will equal the square root of 5 times the square root of 5 is 5. The square root of 5 times 1 is the square root of 5. This is negative 1 times the square root of 5, and this is negative 1. But the important thing here is not that 5 minus 1 is equal to 4, but that this drops out. And we wind up with the answer of 4. So that's the important thing, and it's not necessary, therefore, to multiply, the middle terms. The important thing is that the square root of 5 times the square root of 5 is 5, and that negative 1 times positive 1 is negative 1, and this is the answer to the question. This is how you rationalize a denominator when you're dealing with radicals. Get it? Okay, now which one is the one I'm putting on the exam? Oh, you're kidding. Very interesting. Okay. Anyway, try this one. I don't want to spend too much time on this either, because we have a very important thing coming up after this. But anyway, do this. And the instructions are rationalize the denominator. Okay, everybody in class, do that problem. Let's begin so we can end. So we're going to multiply this by the conjugate, which is this. That doesn't look like a 5, does it? It looks like an S. So let's kind of fix that up a little bit and do that. So that's a 7. And then you've got to multiply the numerator by the same thing. That's the thing. So even though the denominator is going to look pretty easy because it's just going to be this times this and this times this, that's 5 minus 7 is negative 2. That's the easy part. Right? The square root of 5 times the square root of 5 is 5, and 5 minus 7 is 2, right? That works out. And the middle terms just drop out, but I made a mistake here, didn't I? Yeah, I'm trying to get people. I don't want to hear from well, Brendan, I think we did enough damage to you. I don't want to hear from Elisa. I don't want to hear from Sandus. I want to hear from somebody else. What did I do wrong in this problem? Somebody tell me. I don't want to hear from Rose either. No offense. Somebody else.
You didn't multiply the 7s?
Say it again. Sandra, just, I'm saying myself.
You didn't multiply the
It's really
7s.
doing a number on me, I'll tell you that.
I'm so sorry. You
Go
didn't
ahead.
multiply the 7s. You just
Yeah,
brought
I
the 7
didn't
down.
do that correctly. I did that that is something, usually I own up to when I make a mistake, right? But that wasn't, that was an intentional mistake, because I wanted to see how the class would respond. But okay, yes, that's quite correct. 5 minus 49, right? And that comes out to negative 44. Okay, but the really challenging part is right up here in the numerator. So let's go up to the square root of 5 minus 2 and the square root of 5 minus 7. Okay, so this is what we want to do now. And the square, you do this, you get 5. You do this, you get negative 7 times the square root of 5. You do this, you get negative 2 times the square root of 5. And you do this and get positive 14. So, this is what you get. You get 5. Let's bring it down to here. So we can, let me get all these erasers out of here also. We get 5 minus 9 times the square root of 5 plus 14, or 19 minus 9 times the square root of 5. Let me make sure I have that right. This is a 5. This is a -7 times the square root of 5. This is -2. This is positive 14. 14 and 5 is 19 minus 9 times the square root of 5, and that's it. Okay, so we can put the 19 minus 9 times the square root of 5, and that is the answer to the question. Right up there, okay? So that's rationalizing a denominator.